Hello, everyone. So today we're going to be talking about how we can find the area of a parallelogram. So before we get started with our parallelogram, I wanted us to look at first how would we go ahead and find the area of a regular rectangle. So we're going to look at our rectangle first. And we know that when we are looking at our rectangle and we want to find the area is the amount inside of our shape. So if I want to find the area of my rectangle, I can look at the height and the width of my rectangle to determine what the area of the rectangle would be. I can also, if I were to use tiles or have this on a grid, I could look at what would be how many squares or square tiles, or if I was on a grid, how much that would cover, or how much my. So I'm going to go ahead and just draw those lines really quickly, and we can see that we have 4 by 8. So we have 4 rows with 8 columns. And if I were to count all this out, I could also determine. But instead of counting all this out, because that could be really taking a long time, especially if we had like bigger numbers, we can use the mathematical equation, your base times height, or length times width. And in this case, it would be 4 times 8. So I can go ahead and do my 4 times 8 is equal to 32. And then because this is area, this would be inches squared, or square inches. All right, so that is the basics of finding the area of a shape. But when we're looking at a slightly more irregular shape, like a parallelogram, we need to think about how we would find the area of a parallelogram. So thinking about what we know about our rectangle, could we do that same formula? Well, let's look here, because a parallelogram does not have those right angles. So if I were to try to just draw my lines like I did, I'm not going to get perfect squares because, of course, this is not perfect square corners, and so because it's slanted, so I need to think about, well, how would I go about finding the area? I still have from the base of the parallelogram, this has the same measurements. So if I were to take this parallelogram and line it up, it is still 8 inches by 4 inches tall. So that measurement there is still the same, because if you measure from the bottom line here up to the top line, it's still going to be 4 inches, and it's still 4 by 8 inches. But how can I use that to help me figure out the total area of my parallelogram? So one thing we can think about is, well, what is area? Of course, area is trying to determine the space inside of this shape. And so what I can do is, one of the things I can do with my shape is I can go ahead and make a cut. So I'm going to cut my shape right there. Okay, I'm still going to figure out the area of this shape. I'm just going to move it. And I'm going to see, if I move this piece that was right here all the way over to here, what does this now look like? This looks an awful lot like our rectangle that we have up here. So I'm going to see if I can group those. Yes. So if I just group these together, it's now the exact same as my rectangle up here. The only thing I did was I went ahead and moved this piece to, let me see if I can, I moved this piece right here just over to here so that I could see it visually more. And now I have a shape that is exactly the same as my rectangle. So I can see my measurements are still the same. I still have a base of 8 and a height of 4 inches. So I can actually use the same exact equation for my parallelogram, because it still has these same measurements. And if I were to draw my lines, I could still draw it out just like I did with my rectangle. And I could say, okay, I have 4 by 8. And I could draw those really quickly. And then if I wanted to count, I don't think I can draw over that, but anyway. Okay, so, but if I wanted to draw all those lines, count them out, I would still get 32 inches or square inches because it is the exact same area, even though my shape to begin with looked a bit different because of this piece that we were able to move from that one spot to the other. So we can see that with a parallelogram, we can still use the same equation that we would use with a rectangle, which is your base times your height. And it will work. And we could try that with more examples to show that even more. But that is the basics of how you would find the area of